The graph of the derivative f prime is given. Determine the x-coordinates of all points of inflection of f of x, if any. Assume that f of x is defined and continuous everywhere in the interval -3 to 3. We will obtain the point of inflection if the second derivative changes its sign from negative to positive or from positive to negative, but it has to be the second derivative. The graph given is the graph of the first derivative. We can use the graph of the first derivative to determine the sign of the second derivative. If the first derivative is increasing, then the second derivative will be positive. And if the first derivative is decreasing, then the second derivative will be negative. We see that the first derivative is increasing from -3 to -1. This means up to -1, the sign of the second derivative is positive. And then the first derivative, the graph given, is decreasing, is falling from -1 to 0. So the sign of the second derivative is negative. And then after 0, the first derivative is decreasing. And so the sign of the second derivative is negative. What this means is that we will have an inflection point when the second derivative changes its sign, and that is the inflection point at x equals -1, and that is it. There is no inflection point at x equals to 0 because the second derivative does not change its sign at x equals 0. On the left-hand side of 0, the second derivative is negative because the first derivative is decreasing. On the right-hand side of 0, the second derivative is negative because the first derivative is also decreasing there on that interval. And so the only inflection point here for the graph of the function f of x, not this graph, is when x equals -1. And we obtain that information from the graph of the first derivative. We can tell something about the graph of f knowing the graph of the first derivative.